Pretty much everything you do online, whether you're sending an email or hopping on a video call, it's all powered by this unseen delivery service. And it runs on two main protocols, TCP and UDP. They get your data from point A to point B, but in completely different ways. See, one's a total perfectionist, and the other, a reckless speed demon. So let's figure out who's really running your digital life. Have you ever stopped to wonder about this? Why is it that your video call can stutter and freeze, but when you download a movie file, it's always perfect, down to the last pixel? How can one experience be so prone to glitches while the other is absolutely flawless? Well, the answer lies in a choice that's made behind the scenes, a choice between two competing ideas, reliability or speed. And that choice comes down to the two protocols we're going to break down, TCP and UDP. All right, first up, let's meet the protocol that handles the vast majority of all internet traffic. It's called TCP, or Transmission Control Protocol. And look, if you want something done right with zero mistakes, TCP is your guy. The best way to think about TCP is to imagine a really meticulous, almost obsessive-compulsive courier. Before it even thinks about sending anything, it calls ahead to make sure you're home and ready to receive the package. Then it numbers every single part of the delivery, and after it's done, it calls you back just to confirm you got everything and that it's all in the right order. It's totally built for a guaranteed perfect delivery. These three things right here, this is what makes TCP so powerful. It all starts with being connection-oriented. It just will not send a single byte until it knows the receiver is actually listening. And that foundation is what allows it to be so incredibly reliable, guaranteeing every little piece of data shows up. Plus, it's flexible. It can actually sense traffic jams on the network and slow itself down to make sure data doesn't get lost. This is exactly why it's the go-to for anything that absolutely, positively cannot be corrupted. So what does connection-oriented actually mean in practice? Well, it means TCP isn't just going to blindly toss your data out onto the network and hope for the best. Nope. It establishes a formal, dedicated line of conversation between two devices first. It's kind of like making a phone call and waiting to hear hello on the other end before you start talking. And this crucial little setup, it's called the three-way handshake. This whole connection gets formed with a really simple three-step dance. First, your computer sends out what's called a SYN packet. That's basically it asking, hey, you there? Can we talk? The server on the other end replies with a SYN-ACK, which means, yep, I hear you, can you hear me? And finally, your computer sends that one last ACK saying loud and clear. It's only after that little confirmation ritual that the real data starts to flow. Okay, so let's shift gears and talk about the other character in our story, UDP, the User Datagram Protocol. If TCP is the meticulous messenger, then UDP is the speed demon. It lives life in the fast lane and it cares about one thing and one thing only, pure, raw speed. UDP is a sprinter. It doesn't care about handshakes or confirmations or any of that polite stuff. Its only job is to get the data off the starting line and moving toward the destination as fast as digitally possible. It's not worried about whether every single packet gets there or even what order they arrive in. It just goes. So how does UDP start a conversation? It doesn't. There is no polite three-step dance. No, hey, are you ready? No, can you hear me? It just starts sending. It basically assumes the other end is listening and it just blasts data out as fast as it possibly can. You could say it's a system built on hope, but also on incredible efficiency. This whole fire and forget approach is called connectionless. There's no formal channel that gets opened up. The sender just fires data packets in the direction of the receiver and immediately moves on, never even waiting for an acknowledgement. It's like throwing a stack of letters into a mail slot without checking if anyone's home. You just assume they'll probably get there. And right here, this is where we see the big trade-off. UDP gives you the absolute lowest possible delay because it's so incredibly lightweight and has zero setup time. But that raw speed comes at the cost of reliability. It's what we call a best effort delivery system, meaning it'll try its best, for sure, but it makes absolutely no promises. All right, so we've met our two protocols. One is super careful and reliable, the other is ridiculously fast and a little bit reckless. Now, let's put them side by side and see how they really stack up against each other. I mean, you can literally see the difference just by looking at their overhead. That's the extra data they need to manage the delivery. A TCP header is kind of bulky, right? It's loaded with all this sequencing and acknowledgement info. But a UDP header, it's this tiny minimalist 8 bytes. That massive difference in size is a huge part of what makes UDP so much faster. There's just way less data to process for every single packet you send. This table lays it all out just perfectly. You can see the trade-offs so clearly: connection versus connectionless, guaranteed versus best effort, and check out that last row, flow control. This is huge. It's TCP's secret weapon, the ability to sense a traffic jam and slow down to prevent losing data. UDP, on the other hand, it has no brakes. It just sends at full blast, for better or for worse. So, who wins the showdown? Well, here's the thing. Neither of them. It's not about which protocol is better overall. It's always about choosing the right tool for the right job. At the end of the day, the choice boils down to one simple question. Are you prioritizing accuracy or are you prioritizing speed? If every single bit of data has to arrive perfectly intact, you choose the reliable path. But if getting the most current piece of data right now is more important than getting every piece of data, well, then you jump into the fast lane. And you see TCP at work all day, every day. When you're browsing a website, you need all the text and images to load correctly, right? When you send an email, you definitely need the whole message to get there. And when you're downloading a file, a single corrupted bit can make the entire thing useless. All of these things demand TCP's guarantee of accuracy. And this brings us right back to our very first question. Live video, online gaming, voice calls, these all use UDP. Why? Because think about it. In a live conversation, you can't just stop the world and wait for a packet of data that got lost 3 seconds ago. It's much better to have a tiny glitch, a dropped video frame, a little blip in the audio, and get the next piece of data instantly. That's what keeps the whole experience feeling like it's happening in real time. At its heart, the entire system really just comes down to this one fundamental balance. Every single application on the internet is making this choice. Do we need a guarantee of perfection, or do we need information right now? Neither one is better than the other. They're just the right and left lanes of our digital highway. And all this leaves us with one final question to chew on. Today's networks are way more reliable than they used to be. Losing data packets is actually pretty rare. So as that trend continues, are we going to see more and more applications ditching TCP's safety net for the raw, pure speed of UDP? Are we heading for a future where speed always wins out over safety? It's something to think about the next time your video call glitches out. Thanks for joining me.